Mr. B. Dhanasegar is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharathidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. So, we have the subject called compiler design. So, in the previous episode we have seen the structure of the compiler along with what is the role being played by the symbol table and how the errors are being handled in various phases. So, as far as this episode is concerned, we are having the compiler construction tools, then followed by that is bootstrapping of compilers, and also the that is lexical analyzer design and all. So, first we should know that is what is the meaning of a compiler construction tool. So, it is like we have to design the various phases of the compilation. The first phase is the lexical analyzer, which is the scanner, and second phase it is going to be syntax analyzer, that is the parser. Then we have intermediate code generator and code, that is generator, which generates the object code. So, if you come up with programs which are doing everything from the scratch, then it will be a very big target for us to design a compiler. But if you have some kind of tools for constructing a lexical analyzer, constructing a parser, and constructing a data flow engine, constructing a code generator or optimizer, so then we can make use of those kind of tools for the various jobs being played by the compiler design, and then they can be completely integrated to produce the efficient compiler. So, that is what kind of supports we are having for the design of the compiler or compiler construction. So, they are called the compiler construction tools. So, they are the softwares which are producing compilers on giving the specification of the source program, and the target language are called the compiler writing tools. So, now the question is, what are the things supposed to be given as input for those compiler construction tools. So, the first one is what is going to be the lexical and syntactic structure of the source program. The lexical and syntactic structure means you can see that the tokens are the very important or the basic elements of any programming language, but that too is differing for different languages. So, in some languages we are having curly bracket for base or block opening, and in some language we have begin for block opening. So, that is what the lexical structure is differing for different languages. And similarly, even in the syntax also, for example, if I am taking the there is if statement, certain languages they support a keyword called then, and some languages there is no keyword called then. So, see how we are differentiating, or what is the syntactic and lexical structures of your your program. So, what kind of tokens we are having, what are the syntax for the various tokens. So, identifier, whether it should start with a letter, or you can even start with an underscore, or we can start with the hyphen or anything like that. So, this is what the lexical structure of a programming language, and then we have the syntax structure also, how the statements are to be written. For example, the assignment statement, one language may have the assignment operator colon equal, and the other one may have the assignment operator simply equal, and one statement one language may have a terminator semicolon, and another one may have a terminator called dot, and some other language may not have even a delimiter as the statement terminator. So, you first of all you find out the syntax, lexical and syntactic structure of the source program, and give it as input for your your compiler construction tool, so that your compiler construction tool can construct your your lexical analyzer and the parser, that is your scanner and parser. So, next what we need is the description of what is the output to be generated for each source programming, each source language construct. So, what is going to be the output to be produced? We have seen that there is a phase called intermediate code generator in your that is your compiler, which produces the specified intermediate language. So, it can be either a that is your intermediate language like your 3 address code, or it can be a syntax tree, or it can even be a postfix notation. So, what is going to be the target that is language? So, whether it is going to be 3 address statement, or it is assembly language, or it is straight away it is machine language. So, that should be mentioned as input for there is compiler construction tool, that is your input specification and the output specification. The source language specification is the input specification, and the output specification is the target language of your receiver compiler. So, these two are very important things. And another one is the third parameter to be given for your compiler construction tool is about the description of the target program. So, what is going to be the target machine for which we are generating the compiler, because you know that the code optimization phase or even the code generation phase, they are the machine dependent phases. Some portion of your code optimization is machine dependent, and almost everything in code generation is going to be a machine dependent phase. So, when you go for machine dependent phase, so we should know that what are the machine details or the specification of the machine, so that your compiler can successfully generate the code for the machine which is concerned, for which we are supposed to generate the machine language. Especially with what is going to be the instruction set architecture, like the instruction sets, the register structures and list of registers, and the coprocessor availability. So many things are supposed to be provided as input for your compiler construction tool, and hence your compiler, the code generated by your compiler will be optimal in terms of all respects, and it can be executed in an efficient way. So, that is about your compiler construction tools introduction. And now, what are the various compiler construction tools we are having? So, we have 3 or 4 number of compiler construction tools. So, the first one is the scanner generator. So, we should know that what should be given as input for the scanner generator and what is expected to be the output of the scanner generator. The scanner generator is something like, so first you should know that is how the scanners are implemented. The scanners are implemented as transition diagrams. So, given the specification of the token, like the regular expressions or the specification of the token, you provide the specification of the token, that is the stream of regular expressions, as the input for your scanner generator, and then we are converting it into transition diagrams. That is the your regular expressions will be transformed into transition diagrams, and the transition diagrams can be very easily modified into that are converted into programs, and those programs are acting as scanners for your specification. So, if you are interested in constructing a scanner for your source language that is specification, first you identify what are the regular expressions needed for the various tokens to be recognized, and then that is write the regular expression, convert it into finite automata. The finite automata will be then converted into programs. So, we have a tool in your Linux environment called that is your Flex, that is fast lexical analyzer generator. So, we need to give a file called lex file, which will be accepting the various token structures, and that will be producing a program called lex.yy.c, which compiled, which will be given object program, and that object program is nothing but the scanner concerned about your requirement. So, that is a scanner generator. Then followed by that we have the parser generator, because we know that once the scanner has been completely constructed, the parser is supposed to, that is, read the tokens from the scanner generator, your scanner. So, the parser is that is using written using the context free grammars. We write parser means that we are writing that is grammars. You write all the that is statements syntax by using grammar, and then the grammar will be given as, will be written in a file called yawk, that is you can write an yawk file, which is a parser generator, which is supported in your Linux environment, which stands for yet another compiler, and it reads the specification of the grammar, context free grammar, which translates once again into a C file. That C file, once compiled, will be having an object program which acts as the parser for your language, parser for your source program. So, what we need to give as input there is only the source language specification, that is your syntax of each statement available in your program. Maybe for assignment statement, then it is for if statement, then while statement, and then function call. So, for everything expressions, for everything we can specify the syntax. The syntax will be written in the form of context free grammar. The context free grammar is given as input for your yet another compiler like Yacc, and it will be then translating it into C program. The C program once compiled, we will be having the that is your object program, which acts as the parser for your source program. So, that is about your second parser, your compiler construction tool. So, if you have these two, that is your scanner generator and parser generator, the outputs of them can be combined to produce the front end of your compiler. So, you are given a source program, it will be given as input for your front end of the compiler. They will be that is the scanners and parsers, which will verify completely the syntax of your programming language, the syntax of lexical constructs and syntax of syntactic constructs. So, after that the output of this is going to be a parse tree, which will be produced on successful compilation of your code, that is successful that is verification of your code. So, later we will be subjecting them for the code generation phase and all, where we will be generating the object code as part of your compilation process. So, the remaining compiler translators generators are compiler construction tools are, the first one is the syntax director translation engine. So, which is having a collection of routines to intermediate language. So, for example, if you are having the that is your expression syntax, expression is an expression plus another expression, then what should be done is, so we are concerned about generating the intermediate code language means some temporary name is equal to the value of the first expression and the value of the second expression, both are added together. But if you are concerned about generating an intermediate language, which is something like the postfix is to be generated, first to generate the postfix of the first expression, then generate the postfix of the second expression, and then generate the opcode which is connecting these two expressions. So, that will be your postfix expression. So, that is what being done by the syntax director translation engine. So, any intermediate language specification once generated, so we can give it as input for the syntax director translation schemes, which will generate the intermediate code language as per the specification. And another tool is, or another compiler construction tool is the code generators. There is given a specification about your object program from the intermediate language. So, it will translate it into the machine language for the target machine. So, we will be having a program as part of your code generator generators, and what we have is the various functions and procedures which will transform your intermediate language into its equivalent, the machine language. So, the very important concept the translator is going to be your compiler construction tool is one called the data flow engines, which will be mostly used during your optimization phase. So, it is facilitating the gathering of information about how values are transmitted from one part of the program to the other part of your code. For example, if you are concerned about finding the value of a variable at any point, so first you should know where the program variable has been declared, and then we should know what are all the various points where the program variables are all that is the particular variable has been defined, and what is the most recent definition which reaches a particular point of your code. So, once you know that, we can very easily find out what is the value of the expression. So, without knowing what is going to be the exact flow through which we will be having the definitions and their reaches, we call them as use definition chaining. So, what is going to be the recent that is the definition which is reaching the particular point of your code, that is to be identified. So, but that is very important as far as your code optimization phase is concerned. So, that is about your compiler construction tools. We have seen 5 number of compiler construction tools. We just combine the output of all these, we will be having a compiler which will be producing the object version of your code as per your specification from the source language specification. We shall go for a short break. After that, the lecture will continue. Welcome back. We have seen the that is your compiler construction tools. We have seen 5 number of compiler construction tools which are used for generating the compiler from the source language specification, and these specifications for various that is construction tools. So, now the question is that is how the first compiler was generated. So, first of all you should understand that compiler itself is a program written in some high level language. So, if it is a program written in that is a language, so who will be compiling that language, that is who has compiled the program which is representing the compiler for the language. So, that is what the question about how the first compiler was generated. So, we call this process as bootstrapping of compilers. So, we have bootstrapping of loaders, that is which will tell you about how the first program was loaded into your random access memory before the system started that is available for using. So, that is called bootstrapping of loader, that is how the first program is loaded into your random access memory. Now, we are talking about bootstrapping of compilers, how the first compiler was compiled. So, you can recall a situation like once you know that an operator for plus, an operator for complement is available, then we can do all kind of arithmetics with these two itself. So, when you are having addition, it is going to be used as that is a basic operator for multiplication. We know that multiplication is repeated addition, and then if you now know that there is an operator called complement available, then a complemented addition will give you the subtraction. So, subtraction is now available in terms of addition and complement, and once you have the subtraction, we can go for repeated subtraction to produce the division. So, basically all we need is only that arithmetic operation plus and the arithmetic operation is called complement. With the help of these two operations, we can compute or we can perform all the other that is arithmetic operations, even if you are not having direct implementation for all these that is operations. A similar kind of approach is being followed even in your bootstrapping of compilers also. So, it is actually answering the question like how the first compiler was compiled, and first you should know a compiler is characterized by 3 number of languages. One is the source language, that is this language which is going to be translated, the object language, what is going to be the that is object program language which will be produced by the compiler, and third one is the language in which the compiler has been written. So, we use some compiler itself is a program. So, what is the language in which the compiler has been written? So, the language in which the compiler has been written. So, these 3 are the languages describing a compiler. So, now we can represent them in a notation called CLAS. So, as you can see in the slide that this L stands for what is the source language being translated, and the A stands for what is the object language being produced, and S stands for what is the language in which the compiler has been written. So, it refers to the compiler that is C written in the source language S to compile the language L to produce the object language called A. So, that is the meaning of this notation, that is triplet notation CLAS. L stands for source language, A stands for the object language, and S stands for the compiler language in which the compiler has been written. So, now the first step, so what we do is, as I said earlier, that is how we are constructing the multiplication, subtraction, division, exponentiation all from your plus and complement. So, we will be selecting a very small subset of the language, that is actually we are interested in writing a compiler for the language called L. So, we will select an object language, construct small, we will try to construct a compiler, a small compiler for a subset of the entire language. The subset of the entire language means subset of the L language which will be called as S, and for that subset of the language we will write the compiler in the machine language of the compiler itself, machine language of the machine itself. So, we will actually we wanted to have a compiler for L for the machine A with the object language A. That is what this is what we are translating L to A, and the compiler is written in A. So, the why we are having insisting on the compiler must be written in A is, so if the compiler is written in A, it is a program understandable to the machine, because the machine itself is A, the A is the machine language of that machine. So, there is no need of writing, no need of compiling this program. There is a compiler for L to A which is written in A. So, this is what actually we wanted to write, but instead of that we will write a compiler called CSA in A. So, we will select a subset of the entire language called a very small subset of entire language, that is L, which is the subset is called S, and we will write the compiler for this S in the machine language itself. So, we have no escape from this. You write the compiler for the subset language called S, which is supposed to be translated into the machine language called A, and the compiler will be completely written in the machine language called A. So, now this compiler can translate any program written in S into its equivalent object language called A. And how it is written? It is written on the machine language of the machine called A. So, this is what the block being shown. So, the compiler for the source language S to produce the object language A, and it is completely written in the object language called that is A. So, this does not require any kind of translation at all. Now, we can go for the second step. We are writing a compiler for L in the language S, because S is a language for which the compiler is already existing. So, we call it as CLAS. Now, we are writing a language, a compiler for L, but completely in S. So, that is what we are having, the compiler for L, which is supposed to write produce the object version called A. So, now it is written in the language called that is called S. So, S is the source program, the language of your compiler, and any program written in S can be translated by this compiler. So, any program written in S can be translated by this compiler to produce the object version called A. So, a program written in S will be now transformed into a program written in A. Who transform is? It is only the CSAA. So, now I am compiling the program CLAS by using CSAA to produce the object language called CLAA. So, what this compiler on the left hand side is? It is a compiler for L, but written in S. Now, it is compiler for L written in A. So, this is what actually we wanted to have. So, now this will be your compiler which is capable of translating this L into object language, and this need not be compiled once again, as it is already written in the language called A. So, this is what the step being followed for writing a compiler. So, this step can be even that is number of steps can be, we have seen that it is going to be two step process. First you write the compiler for S, then we will write the compiler for L from S, but it can even be increased to more number of steps, so that the amount of translation being done in various stages can be very less. So, this process is called the bootstrapping of compiler, and so now this could be extended even for that is a different machine also. Suppose if you want to that is produce the code for a different machine, there is a compiler for a different machine. So, now this is going to be the process here. We have the compiler for L A, and now we are writing a compiler. We need a compiler for B. B is another machine. So, we are supposed to write a compiler for that is L B, but written in L. So, this program can be compiled because of what? We have a compiler already written for L. So, what will be the target language is going to be CLB, that is your L written, the program written in L can be now translated into A. So, now what we will be doing is, so this program, that is your program written in A or program in A, the compiler in A, which is meant for L to B translation, is once again used for compiling the same program CLBL. So, what happens here is this L to that is this L will be transformed into B. So, we will be having CLBB. So, we started with CLAA, which is a compiler written for L to produce the object version A, but it is written in A, which is now executable in a machine called A. But we wanted to go for a new machine called written in B. So, that is what we wanted to have, CLBB. So, we will use this compiler first to produce another compiler version, which is we called CLBA, and the same program once again CLBL will be given as input for CLBA to produce CLBB. So, we have that is a different types of compilers called cross compiler. Suppose if you find compiler is translating the program and which is not for the current machine, which will be for a different machine. So, a compiler running on a machine but producing object code for a different machine will be called as a cross compiler. So, that is about your bootstrapping of compiler. So, whatever be the language complexity we are having, even if you are interested in developing the compiler from the scratch, then it is possible to come up with the compiler for that, but in a stage by stage manner. More the number of steps available, then more ADC for the translation. Otherwise, we would write a big compiler in a single stretch itself. So, this is an alternate given for there is compiler construction tools. So, you can either go by the compiler construction tools which are already existing programs, or you can go for bootstrapping of compilers, so that we will be able to have the program translation much easier. So, what we have seen is the various there is compiler construction tools, so which are meant for the producing the compilers from your source language specification, and then we have seen the bootstrapping of compiler also. So, which will be useful in generating the very first that is compiler from your language specification. So, we can come up with a compiler in any high level language, provided we follow the concept of bootstrapping. So, the possible questions here, so most of the time we will be having questions from that is your compiler construction tools. What are the compiler construction tools and what they are all actually doing. And another thing is, given a compiler construction tool, what is the input specification for that and what is the output specification from that. So, a compiler construction tool requires a proper specification of its input and output, so that it will produce a program which does the required job. And another question is going to be your what is going to be the like your bootstrapping of compiler, that is how the first compiler will be generated, which will be written in a high level language program for which the compiler was not already existing. So, if a program for which the compiler is already existing, then it is okay, but if the program for which the compiler is not already existing, then bootstrapping is the solution for finding the compiler for the program. So, bootstrapping will help you in identifying the finding the compiler for any high level language program, even from the scratch also. With this, I complete this episode. Thank you all.